Banana chips are the only good thing. Well,
okay.
The best thing.
So, yeah, we went over, I believe we went over question 8, 9, 10, and 11. And maybe 12. But I'm going to kind of review some of it again anyway because I don't remember. You do have bookwork. Oops. You do have bookwork due tomorrow. It's up on the board. I got the text scheduled, so you'll get that. The plan for today, after we go over this homework, is I got a video I want you to watch. It's about 2 minutes long. It's a really good video on vapor pressure, what we've been talking about. Bookwork's on boiling and vapor pressure. We're going to take a little bit of notes about boiling today. I had planned on doing a demo in the back. You guys turn around and see that glass jar looking thing. Bell jar, it's called. You guys maybe the wall's blocking it. It's a vacuum chamber.
We should do
Anybody has marshmallows at home? You want to bring in one tomorrow? That'd be cool. We'll put it in there. And
We put a dried pineapple in there.
nothing will happen.
That's fine.
So I wanted to show the demo. I didn't get to it with period 2. I doubt I'll get to it with you guys, but that's the plan. Okay, so who can tell me, what does this line here mean? 101.3. What does that line mean?
Pressure at STP. Right?
What's the T stand for?
Temperature.
Right. So what's this? Just standard pressure. So
Yeah.
it's heat, not so. You're right. Everybody, but that's common. A lot of students say STP, STP. Just the SP technically. Standard temperature is separate. Standard pressure, 101.3. So what did we learn about these points right here? What are those points called?
Boiling points.
Boiling points, but specifically Xavier. There's another word that comes in front of boiling point. Anybody helping out?
It's in our notes, isn't it?
Normal boiling point. What'd you say? Good job. Good job. Normal boiling point. Yes, that's the normal boiling point because that's where these liquids boil at standard pressure. What happens if we lower that standard pressure? Like if we climb a mountain, we're boiling rice on top of the mountain. What happens if we lower the air pressure? What happens to the boiling points?
They go down.
Right, so if we lowered the air pressure to 60, notice what happens. All the boiling points now are here, here, and here. They're lower. The lower the boiling point, right? As your air pressure decreases, your boiling point decreases, and that's because of those two pressures, or vapor pressure, air pressure. When they equal, it boils. So that's why when you decrease air pressure, the boiling point goes down because you don't need as much pressure pushing up. So we're going to write that in our notes later, but I just wanted to reiterate that, okay? Kind of go over that one. So that was basically talking about number 10 and 11. We went through, I know we went through 11. So I'm going to move on. And we're going to go over 12. Why the boiling point varies with atmospheric pressure. Just kind of went over that, but I'm going to kind of draw it again. So we got, that's weird. We got 100 degrees here. This is at sea level, or basically in this room, water boils at 100. On top of Mount Everest, anyone remember what it boils at?
59.
69 degrees. So we have vapor pressure pushing up, okay, against the air pressure pushing down. Well, at the pressure in this room, the air pressure in this room, you need to give water a lot of energy to actually boil. But on top of Mount Everest, you don't need to give it as much energy because the weight of the air, if you want to look at it that way, or the force of the air, force of the air pushing down is much less. Okay, on top of Mount Everest. So since this force is smaller, this force is also smaller. So it doesn't have to be as hot to push back, right? Because the hotter it is, the more vapor it produces. So the cooler it is, that means there's less air pressure pushing down. That's the answer to 12. Why boiling point varies with atmospheric pressure? Because the pressures have to equal, and if there's less pushing down, you need less pushing up. And then the last thing we talked about was, whose rice was going to cook faster? Right, who were the people? Blake, you were down at sea level, you're here, and Steph was up at the top. Whose rice takes longer, or fat, which one? What's the difference between cooking rice here versus here? Yeah, this is going to take longer to boil, right? It takes longer to reach 100, but it's hotter, so the rice cooks faster. This will start boiling faster, but take longer to cook because it's not as hot. So that was, we talked about higher elevation directions on like rice packets or boxes or whatever. So that's why. That's why it takes longer. It's not as hot. Okay, so that was 12. 13. Oh, I don't know. Zach, what do you think? Number 13.
Is it this one?
Which one? Number 13? Yeah.
No, this is the homework, right?
Yeah, yeah, at the bottom, number 13. You can't really see
Oh,
it.
it's cut off.
Yeah, it just says, looks like 3.
Decreases the energy.
Why does the evaporation lower the temperature? Why does evaporation lower the temperature of the liquid?
I don't know, I just said it decreases the energy.
Okay. You're not wrong, you just need more. So, the energy of the liquid decreases. Yeah, sort of. How? Remember, energy can't be created or
That's
destroyed.
kinetics,
Yep, you're on the right track. Someone help me out. How come the liquid stays cooler as it evaporates? You ever feel anything evaporate off your hand, like alcohol or acetone?
It takes
or
the
nail
heat
polish?
away.
It feels cooler, right? When it evaporates, if your hand feels cold, what takes the heat away?
The stuff that evaporates. So like when you sweat the beads, they like absorb the heat and
Right.
evaporate.
Good
When
job.
They get the energy.
So in here, the particles have a decent amount of energy, okay, bouncing around fairly quickly. The surface gains enough energy, they break free, right? So they start evaporating. What happens is the energy that's in the liquid goes away, goes with the vapor, leaving the liquid cooler, right? Leaving the liquid cooler. That's why boiling water can't ever go above its boiling point. So water in this room, if it's boiling, it's going to be around 100. Let's say 98, okay? Let's just say 100. So water's boiling in this room on a hot plate. If I turn the hot plate up to 10, so it boils faster, does that make sense? Does the temperature of the water go up?
It would go up, but it wouldn't go past 100 degrees, right?
So let's say it was at 100, but I had it on medium heat. I turned it up to high.
It wouldn't go up. It would just evaporate faster.
Right,
Because
so-
more energy.
This is why. This question helps us understand why the boiling point is the highest temperature a liquid could ever be. The vapor can be hotter, but the liquid can only be as high as its boiling point, because then it starts to evaporate and it takes the energy with it, leaving the liquid cooler, and it maintains that temperature. So liquids maintain their temperature when they're boiling because the vapor is taking the energy, extra energy with it. So it can only get as high as its boiling point. No matter how hot you have the hot plate, or if you're boiling water at home, no matter how much energy you give it, it's never going to go above the boiling point because the energy goes with the vapor. All right, flip it. Now let's look at this one. Let me back up here. So this is a good regents question. I got this right from a regents. I don't know which one. The way they show the question, the wording, everything, regents level, it's very good. What is the vapor pressure of liquid A at 70 degrees? So my first problem with this says pressure, not vapor pressure, but they want you to treat it the same. Some students get confused with that. They read the question, it says vapor pressure, they look at the graph, and all it says is pressure. But why they don't label vapor pressure is because of the definition of boiling point. When vapor pressure equals air pressure, it boils. So when the vapor pressure of this liquid, so let's say we're right here, the vapor pressure is 300, well that means the air pressure is also 300, so that temperature right there is where it's boiling. Let's say we're right here, they're both 500, the vapor pressure and air pressure, so right there, that's where it's boiling. So in other words, they didn't need to label vapor pressure. When they say vapor pressure, it means pressure. So I may be kind of making that more complicated, but I wanted to explain that. So anyways, what is the vapor pressure of liquid A at 70? You must include correct units. Edwin, what do you think?
700
700 what?
mmHg.
Yes, tell me how you got that. Good job.
I just went 70 degrees
Went to 70 degrees?
and went up the line.
Went up, which line?
That line.
B?
That you're on.
No, when do I stop?
The A line.
All the way up to A, good. And then I look to the left, correct?
Yep.
There we go. Good job. 700 millimeters of mercury. Good job. You good? What's
Dude.
Do you have to go to the bathroom? Can you wait?
Yeah, just wait.
Okay.
That's a really weird.
Yeah, that's.
Sorry, this is what gets you.
She's gonna call the police on you in a minute, so stop doing that. 69. At what temperature does liquid B have the same vapor? This is not an easy question, so listen up. At what temperature does liquid B, so that's this line here, have the same vapor pressure as liquid A at 7? So we just answered number 68. Right here, 700 at 70. Right, liquid A, 700 millimeters of mercury, mmHg, unit of pressure, at 70. What temperature, Jake, does B have the same vapor pressure as A at that point? So what temperature does B have the same vapor pressure as A at 70 degrees?
Degrees.
114? Tell me how you got that.
Nice. 700.
You went to 700
One across.
to line B.
Yeah, to the line B map.
Yep.
Straight down.
And then went straight down. Very good. And that's about one. I got a little squirrely there, but that's about 114. Very good. 114. So the answer to this question, 114 degrees Celsius, use units, right? If you're confused, at 70, A has a 700 millimeters of mercury pressure. So where does B have that same pressure? At 114. At 114. Good. Good job. Last question. Kristen, what do you think? Which liquid will evaporate more rapidly? Explain in terms of intermolecular forces.
Liquid A will evaporate first.
Very good. A will evaporate first.
The forces are weaker.
The forces are weaker. Very good. But let me before we move on, let me explain that to everybody. Liquid A has a higher vapor pressure at every single temperature. Every temperature, liquid A has a higher vapor pressure. What does that mean? What does that mean? What's vapor pressure? I know Jake knows, but don't say it.
Oh,
What's vapor pressure?
It's when pressure equals. What?
What's vapor pressure? What is the definition of vapor pressure? How about Isla?
Vapor. Oh.
Hold on. Sorry, I'll come back to you. What collides? Very good. What kind of particles? Air particles, gas particles, or vapor particles? You're right. Everything you said is perfect. It's when the particles start colliding. That's what creates pressure. Very good. Vapor. Right. Yeah, I know it's obvious. I'm just making you say it. Good job. Yes, when vapor particles collide, that causes vapor pressure. So Ryan,
I was
Why?
just gonna read you the def. Oh, what's up?
why does A have a higher vapor pressure than B at all temperatures?
It has weaker.
Has
forces
weaker
attractors.
forces, like Kristen said, what does that mean? How does that relate to a higher vapor pressure?
It has has a lower boiling point, right?
Good. That was the next thing I was going to talk about. It has a lower boiling point. We know that. Lower
I'm
boiling
confused
point.
with your. Say the question again.
Yes, okay. Relate the fact that A has a higher vapor pressure at every temperature. And what does that have to do with their forces of attraction, or its forces of attraction? So in other words, let me rephrase that. If A has weaker forces of attraction, why does that mean it has higher vapor pressure?
Well, it says right here with this asterisk, it says liquids with a higher vapor pressure
Have
weak
weaker forces,
of
right.
attraction.
So that's like,
That's
you
the
want
rule.
to get an 80-something on the regents, good. But if you want a 90-something, answer this question.
Either one's good. So.
That sounded like.
Yeah, but it's not. No, a name's not the number.
Oh, because with the weaker forces, they evaporate quicker, so they collide more.
There you go.
There.
Weaker forces mean they evaporate more. There's more vapor, so they collide more often. Very good. So, last thing. What's the normal boiling point of A and B on this sheet? What is the normal boiling point? I gotta help you out here. Standard pressure is 760, right about here. 760 mmHg. So what's the normal boiling? Everyone look it up. Do it yourself right now. What's the normal boiling point of A? What's the normal boiling point of B? They didn't ask that. I'm asking that. Don't say it out loud.
Hey, Mr. McCoy, I know I've been a pain the past couple of days, but can I borrow a pen? Now I have like
Past
pens.
couple days. When school starts? September what? 6th?
I've been bringing my pens
Something like that?
the whole. That's a pencil.
Oh, right.
Oh,
It makes you feel weird. I
Yeah,
forgot.
gives me goosebumps.
Yeah.
Yeah, I learned that.
How does it give you? I just don't understand how it gives you goosebumps.
That'll do. Cause like, what happens is this is purple. No, I'm joking. Perfect. What happens is when the graphite, it just like layers up. It just doesn't like. I
See,
don't
you
like
can't help but think about the chemistry behind it.
it. Yeah, no, don't worry.
So, come on, standard, oh, I got all screwed up here. Standard, pressure is 760-ish, right around there. What is the normal boiling point of A, Blake? About? 72, yeah, I'm good with that. Right about here. Good job, 72 degrees Celsius. Taylor, normal boiling point of B.
Like 116.
116, yeah, I'm good with that. That's about right there. Good job, okay? Good job. Alright, you can put that away. I'm going to show you the video now, then we'll take some notes. Bree, can you get the lights, please?
Are we gonna do the demo?
You go.
Today?
Video?
Just go. I'll wait for you. Go.
Are we gonna do the
You're pretty
demo?
quick.
You know, since no one's here today, needs actually be also next to
Are we gonna do the
I'll
demo?
keep that in mind at the end of the period.
Are we gonna do the demo today?
Probably not.
Why not?
I just don't think we're gonna have time.
Man, that's unfortunate. I got heartburn. You got any Tums? What? Dude, before I got
Sometimes you have blank of the mouth.
diarrhea of the mouth.
That's impossible. Ryan's always talking.
Nah, but like, before I go to bed, every night, like right as I'm about to fall asleep, I get really bad heartburn and I had to get Tums every time or drink a glass of milk. Every time.
Milk.
That was like one
It
day.
coats the inside, but it's still slightly acidic, so it's kind of a.
What are you
So
supposed
Tums
to
is
drink?
my best bet.
Nothing. Water and Tums are the best. Water and
But
Tums.
milk makes
But let me ask
milk
you
is
this.
instant relief and then I can go to
Because
bed.
it coats your
My
esophagus.
doctor says it's because I bite my fingernails.
Let me ask you something. What time do you go to bed usually?
I don't know. It's random.
Like random, like 11?
Well, it depends on what I'm watching on Netflix. Yeah, so like 11. We'll just go with
Let's
11.
just say 11. Okay. What time do you eat dinner?
I don't know, like 6, 5, 6
Do you
o'clock.
eat anything before you go to bed?
No.
Really?
No, my mom won't let me. I'm like, Mom, can I have these banana chips? And she's like,
Nope.
nah.
Go to bed with your heartburn.
Yeah.
And the reason I ask you is because sometimes if you eat really close to bedtime, you get heartburn because you're not digesting completely, and when you lay down, it starts.
I just have my vitamins before I go to bed. Like little Flintstone gummies. Those things
The
are awesome.
gummies?
Yeah. These things are great.
This is all being recorded, by the way. Yeah, that's unfortunate. Just,
Look at Charlie Boone's photo. Honestly, I think it's Charlie.
no,
Can you
that's
do that?
Well, hold on.
alright,
Can we watch
I'm
it?
gonna give
Look
him,
up Bumblebee.
30 more
Look up
seconds.
Bumblebee Tuna, and then go find Mr. Google's video.
What?
I'm serious. Look up Bumblebee Tuna.
No.
It's Mr.
Look up
Goble.
Chubby Cupcake Kid.
It's Mr. Goble in college, and he had to make a video, and he needed Bumblebee Tuna. It's so